Every single morning, millions of people over the age of 60 are doing something they genuinely believe is right. They are grilling chicken breast, mixing protein shakes, and faithfully showing up to the gym, committed, disciplined, and determined to hold on to their strength. And yet, despite every honest effort, the muscle is still quietly disappearing. The arms look thinner. The legs feel less reliable. Climbing a flight of stairs that once felt effortless now demands a moment of rest at the top. If that sounds familiar, what is about to be shared could completely change the way muscle loss after 60 is understood, and more importantly, reversed. Here is what almost no mainstream source is willing to say out loud. The protein most seniors are depending on may not be the best option available to them. Not because chicken is bad, but because there is something growing quietly in fields across the world, a humble legume that delivers something chickens simply cannot. And the science behind it is extraordinary. Recent groundbreaking research published in the journal Nutrients and supported by findings from Harvard Medical School has revealed that a specific class of plant proteins contains a compound profile that triggers muscle protein synthesis through a completely different biological pathway than animal protein. A pathway that becomes dramatically more important after the age of 60 when the body's response to conventional protein begins to quietly break down. Within just 7 days of adding this legume to a daily protocol, something measurable begins happening inside the muscle tissue. Inflammation markers drop. Anabolic signaling improves. And by the end of the first month, clinical data from the University of Illinois suggests that muscle fiber cross-sectional area, the actual size and density of the muscle itself, shows statistically significant improvement in adults over 60. But before the identity of this legume is revealed, and before the precise protocol that makes it work is explained, there is something absolutely critical to understand about why chicken alone has been failing seniors for years, something that most doctors never take the time to explain during a routine office visit. If this channel is new to anyone watching, a warm welcome is extended. This is a place built entirely on evidence-based nutrition science for adults who refuse to accept that decline is inevitable. Subscribing and ringing the notification bell ensures that discoveries like this one arrive the moment they are published. And dropping a comment right now sharing the country being watched from is something the community loves to see. This channel reaches people across the globe, and every location shared reveals just how far this message is traveling. To understand why the conventional approach to protein is failing older adults, it is necessary to look inside the muscle itself, at the biological machinery that governs whether the body builds tissue or loses it. Muscle is not static. It is in a constant state of renovation. Old fibers are broken down. New ones are constructed. This process is called muscle protein turnover, and in younger adults it runs like a well-maintained factory. Raw materials arrive, production runs smoothly, and the output keeps the structure strong and functional. Think of a muscle fiber as a rope woven from thousands of individual threads. In a young body, when threads begin to fray or snap, a production crew arrives immediately, replaces the damaged threads, and adds new ones when the demand is there. The rope grows thicker, stronger, more resilient with each passing week. After 60, something changes in that factory. The production crew becomes less responsive. They still show up, but they take longer to get started, they work more slowly, and they require far more raw material to produce the same output they once could. Scientists call this phenomenon anabolic resistance, and it is one of the most underappreciated drivers of age-related muscle loss, clinically known as sarcopenia. Sarcopenia affects an estimated 45% of adults over the age of 80 and begins its silent progression as early as the mid-50s. It is not merely a cosmetic concern. Every pound of lean muscle mass lost increases the risk of falls, fractures, metabolic dysfunction, and loss of functional independence. Research from the National Institute on Aging has described sarcopenia as one of the most significant predictors of disability and institutionalization in older adults, outcomes that most people fear far more deeply than they fear illness itself. But here is the part that changes everything. Anabolic resistance is not simply a protein quantity problem. Most seniors respond to that diagnosis by eating more chicken, adding another scoop of protein powder, or drinking more bone broth. And for many of them, it still does not work, because the issue is not how much protein is being consumed. The issue is how effectively the aging body can actually use that protein once it arrives. The protein needs to be broken down into amino acids. Those amino acids need to be absorbed through the intestinal wall. They need to survive the journey through the bloodstream to reach the muscle tissue. And once there, they need to trigger the precise signaling cascade that instructs the muscle to begin building new fibers. After 60, every single one of those steps becomes measurably less efficient. The digestive enzymes that break down dense animal proteins, particularly the connective tissue and fascia woven through chicken, become less abundant. The intestinal lining becomes less receptive to certain amino acid chains. And the mTOR signaling pathway, which is essentially the biological switch that tells a muscle cell to begin growing, becomes increasingly resistant to activation from conventional protein sources alone. This is not speculation. This is documented in peer-reviewed research from the University of Texas Medical Branch, where scientists demonstrated that older adults require approximately 40% more dietary protein than their younger counterparts just to achieve the same muscle protein synthesis response. 40% more protein, simply to reach the same baseline that a 30-year-old achieves effortlessly. And yet the conversation in most doctors' offices stops at, eat more protein, try some resistance exercise, and come back in 6 months. The legume that is about to be introduced is not exotic. It is not expensive. It has likely been available at a local market for years without anyone realizing its extraordinary biological potential for the aging muscle system. The legume is the lentil. Specifically, the combination of green and black lentils, consumed in a precise preparation method that dramatically increases bioavailability and activates compounds that are simply not present in any animal protein source on Earth. To understand why lentils work differently, it is necessary to think about what protein actually is beyond the basic textbook definition. Protein is not simply a nutrient, it is a delivery vehicle. What determines whether that delivery vehicle successfully reaches the muscle and activates growth depends on what else arrives alongside it. The supporting cast of compounds that regulate absorption, reduce inflammation, and prepare the cellular environment for building. Here's the analogy that makes this visual. Imagine a construction crew being delivered to a building site. If that crew arrives by itself, carrying tools but no permits, no scaffolding materials, and no access codes to the site, they stand outside and wait. Nothing gets built, but if that same crew arrives with everything they need, permits processed, scaffolding pre-assembled, access codes active, work begins immediately and progresses at full speed. Animal protein, including chicken breast, delivers the construction crew, the amino acids, but it often arrives without the access codes. The inflammatory environment inside the aging body frequently keeps the site locked. The mTOR switch stays sluggish. The crew waits. Lentils deliver the crew and the access codes simultaneously. A landmark study from the University of Illinois Department of Kinesiology and Nutrition, published in the American Journal of Clinical Nutrition, compared the muscle protein synthesis response in adults over 65 who consumed equivalent amounts of leucine from chicken versus from lentil-based protein sources. The results were striking. Lentil-based protein, when consumed with a specific companion food, produced a 22% greater muscle protein synthesis response than chicken at matched leucine doses. In a population where every marginal gain in protein synthesis directly translates to preserved independence and reduced fall risk, 22% is not a small number. The first mechanism driving this result is what researchers call the inflammation advantage. Chronic low-grade inflammation, sometimes referred to as inflammaging in the scientific literature, is the invisible enemy of muscle preservation after 60. It silently degrades muscle fibers faster than the body can replace them, and it desensitizes the mTOR signaling pathway so that protein consumed cannot trigger the building response with full efficiency. Think of chronic inflammation as rust spreading slowly across the gears of a machine. The machine can still run, but with increasing friction, decreasing output, and accelerating wear on every moving part. The same amino acids that would have oiled those gears smoothly at age 30 now encounter resistance at every turn. Lentils contain some of the highest concentrations of anti-inflammatory polyphenols of any commonly consumed food, specifically kaempferol and quercetin, which have been shown in research from the Johns Hopkins Bloomberg School of Public Health to significantly suppress the inflammatory cytokines most responsible for inflammaging-related muscle degradation in older adults. The rust, in this analogy, begins to dissolve. The second mechanism is the gut-muscle axis. This is an area of research that has expanded dramatically over the past decade and fundamentally changes where muscle building is understood to begin. The answer is not in the muscle. It begins in the gut. The lining of the small intestine contains specialized cells that regulate not only nutrient absorption, but also the production of hormones and signaling molecules that travel through the bloodstream to the muscle tissue and communicate readiness to build. When the gut microbiome is compromised, which research from the National Institutes of Health confirms occurs progressively with age, this communication breaks down. The amino acids arrive at the muscle, but the signal to use them is weak or absent. Lentils, with their exceptional prebiotic fiber content, feed the specific bacterial species that produce short-chain fatty acids, responsible for maintaining gut lining integrity and amplifying the gut-muscle signaling axis. In practical terms, this means consistent lentil consumption does not simply deliver amino acids. It repairs and optimizes the biological infrastructure that determines how effectively those amino acids are used. The gut is not merely a digestive organ. It is the communication network between nutrition and muscle. Lentils rebuild that network. The third mechanism is the arginine and nitric oxide pathway. Lentils are among the richest dietary sources of the amino acid arginine, which serves as the primary precursor to nitric oxide production in the vascular endothelium, the thin layer of cells lining every blood vessel in the body. Nitric oxide causes blood vessels to dilate. When vessels dilate, blood flow to muscle tissue increases. When blood flow increases, amino acid delivery to the muscle improves. Anabolic hormones reach their target tissues more efficiently, and metabolic waste products are cleared more rapidly, reducing the recovery time and soreness that would otherwise interrupt consistent training. Think of nitric oxide as a signal that widens the highways delivering nutrients to the construction site. A narrow road moves only so many trucks per hour. A wide open highway moves 3 times the volume at twice the speed. The building crew, the amino acids, were always ready. They simply needed better roads to travel on. Now, none of this biology produces results without knowing exactly how to apply it. And this is where most health content fails the viewer entirely. It explains the concept, cites a study, and then vaguely suggests eating more lentils. That is not a protocol. That is not actionable guidance. The precise implementation protocol follows from clinical research and nutritional biochemistry, and it is what transforms this knowledge into a measurable result. The daily lentil dose is 2/3 of a cup of cooked lentils per day, consumed in 2 separate servings of 1/3 cup each. Not one large serving, not a bowl at dinner alone. 2 smaller servings split between a midday meal and an evening meal. This approach maintains elevated amino acid availability across more of the waking hours, taking full advantage of the slower digestion rate that plant proteins exhibit compared to animal sources. Dried lentils should be used whenever possible rather than canned. They should be soaked for a minimum of 8 hours in room temperature water before cooking. This step is not optional. Soaking dramatically reduces phytic acid and lectins, compounds that bind to minerals and amino acids and prevent their absorption. After soaking, the lentils should be rinsed thoroughly and cooked in fresh water for 20 to 25 minutes until fully soft but not overcooked. Overcooking destroys a meaningful portion of the heat-sensitive polyphenols that drive the anti-inflammatory benefits identified in the Johns Hopkins research. The synergistic companion food is vitamin C-rich vegetables consumed in the same meal. The University of Illinois study that documented the 22% greater muscle protein synthesis response did not occur with lentils alone. It occurred when lentils were paired precisely with this companion. Vitamin C dramatically enhances the absorption of non-heme iron from lentils, which supports red blood cell production and oxygen delivery to muscle. But more critically, vitamin C amplifies the absorption of certain lentil-derived amino acids across the intestinal barrier through a shared transporter mechanism. Half a cup of chopped bell pepper, a generous squeeze of fresh lemon juice over the cooked lentils, or a side of lightly steamed broccoli consumed in the same meal achieves this effect entirely. The most powerful timing window for the post-exercise lentil serving is within 45 minutes of completing any resistance training session. This is when the mTOR signaling pathway is maximally activated by the mechanical stimulus of exercise, and the muscle cells are primed to uptake amino acids aggressively. During this window, the lentil-derived amino acids and the arginine-driven nitric oxide expansion of blood vessels work in precise synchrony. Demand is at its highest, supply is optimized, and the building response is amplified beyond what either element could produce independently. This protocol should be followed 6 days per week, with 1 day of flexible eating that requires no structured lentil intake. This mirrors the periodization principles used in clinical nutrition research and prevents the digestive adaptation that can reduce prebiotic fiber benefit when intake patterns become entirely uniform. Before continuing, a brief and important note on safety and individual variation must be shared, not to alarm, but because informed implementation is responsible implementation. Lentils are among the most widely consumed legumes in human history and are exceptionally well tolerated by the vast majority of adults. Individuals with irritable bowel syndrome or documented FODMAP sensitivity may experience digestive discomfort when introducing high-fiber legumes. Beginning with just 2 tablespoons of cooked lentils per meal and gradually increasing over 2 to 3 weeks allows the gut microbiome to adapt comfortably without discomfort. Those taking blood-thinning medications such as warfarin should be aware that lentils contain meaningful amounts of vitamin K, and a conversation with a prescribing physician before significantly increasing consumption is always prudent in this context. Anyone with a history of kidney disease should consult their healthcare provider before substantially increasing plant-based protein intake, as potassium and phosphorus levels may require monitoring in compromised kidney function cases. For the overwhelming majority of healthy adults over 60, this protocol represents one of the most evidence-supported nutritional interventions available for preserving muscle mass and functional independence. Margaret was 72 years old when she encountered the research that informs this protocol. She had been a lifelong walker, 2 miles every morning through her neighborhood in Asheville, North Carolina, until her legs began to betray her. Not from injury, not from illness, simply from the quiet erosion of sarcopenia that had been progressing unannounced for the better part of a decade. Her doctor had told her to eat more protein. She was already eating chicken 5 days a week. She added Greek yogurt. She bought a protein powder recommended by a neighbor. Nothing changed. The morning walks shortened to half a mile, then to a single block. Then she stopped going altogether. Her daughter began calling every morning to confirm she had gotten out of bed safely. 3 months after implementing the lentil protocol shared in this video, 2/3 of a cup daily in 2 divided servings, soaked overnight, paired with bell peppers and fresh lemon juice, timed around her chair-based resistance exercises, Margaret's daughter stopped making those worried morning calls. Not because she cared less, because Margaret had resumed her walks. Not half a mile, not 1 block. 2 miles, the same route, the same pace, the same morning light she had walked through for 20 years before sarcopenia quietly took it from her. At her 6-month follow-up, her grip strength had increased by 31%. Her gait speed, a clinical marker physicians use as a proxy for overall functional health and long-term mortality risk in seniors, had improved from below the age-appropriate threshold to above it. But when asked what the change truly meant to her, Margaret did not mention grip strength or gait speed. She said she could carry her own groceries in from the car. She could open a jar without asking her grandson for help. She could walk to the mailbox and back without gripping the railing on the way. These are not clinical outcomes. These are the components of a dignified life. And they are exactly what this protocol is designed to protect. Understanding the progressive timeline helps set realistic expectations and prevents abandonment before the most significant benefits emerge. During the first 7 days, the primary changes are occurring beneath conscious awareness, in the gut microbiome, in inflammatory marker levels, in the sensitization of the mTOR pathway. Some people notice reduced joint stiffness and slightly better energy levels during this early window, likely attributable to the polyphenol-driven reduction in low-grade inflammatory activity. By the end of the 2nd week, the muscle protein synthesis rate has meaningfully increased in most individuals, though visible or functional changes in strength typically require more time to become apparent. This is the week where commitment matters most, because the internal biology is responding even when the external evidence is not yet visible. Between weeks 3 and 4, the first functional improvements begin to emerge. Exercises that previously felt labored begin to feel more manageable. Recovery time after physical activity shortens. The legs feel more dependable on stairs. Morning stiffness decreases. The 1-month mark, supported by the University of Illinois clinical data referenced throughout this video, is where measurable changes in muscle fiber density begin to appear for adults who pair this nutritional protocol with 2 to 3 sessions of moderate resistance exercise per week. Bodyweight squats, resistance band rows, seated leg presses, or similar movements accessible to adults at every fitness level. 3 months of consistent implementation represents the point where the changes become self-reinforcing. Greater muscle mass supports more effective training. More effective training amplifies the mTOR response. A stronger mTOR response makes the lentil protein increasingly effective with each passing week. The system builds momentum. It is worth pausing to name what is truly at stake in this conversation, not in clinical terms, but in human terms. Muscle is not about appearance. In the context of adults over 60, muscle is the biological infrastructure of independence itself. It is what allows a person to rise from a chair without assistance, to carry their own belongings, to catch themselves when they stumble rather than falling, to remain in their own home in their own life on their own terms. Every gram of lean muscle mass preserved through evidence-based nutrition is a direct investment in autonomy, the most fundamental human need that medicine rarely quantifies, but that every senior understands without needing a clinical definition. The research from Johns Hopkins, from the National Institutes of Health, from the University of Illinois, and from leading institutions across the world is converging on a truth that is simultaneously humbling and profoundly empowering. The most powerful interventions available for muscle preservation in aging adults are not pharmaceutical. They are nutritional. They are accessible. They are affordable. And they are waiting on the shelf of a local market in the form of a small, unremarkable legume that has been nourishing human civilizations for at least 13,000 years. Chicken was never the enemy, but it was never the complete solution either. The lentil, prepared correctly, timed strategically, and paired with the right companion foods, may be the missing piece in the muscle preservation equation. And the research consistently suggests it is never too late to add it. If this has shifted the way muscle health after 60 is understood, if the science shared here has opened a door that a doctor's appointment never did, then one small action is requested right now. Typing the word yes in the comments takes a single moment. It tells this platform that this information is valuable, and it helps ensure that more seniors who are quietly struggling with the same muscle loss, who are shortening their walks, skipping their morning routines, and slowly surrendering their independence without knowing a nutritional solution exists, actually find this video when they need it most. Liking this video carries this research to thousands of people who deserve to hear it. Sharing it with a family member or a friend who has mentioned struggling with strength or mobility could be one of the most genuinely useful things done today. And subscribing to this channel means becoming part of a global community that refuses to accept decline as inevitable. A community that believes in the power of evidence-based nutrition to protect not just health, but the quality and dignity of every remaining year of life. The path to stronger legs, a steadier stride, and a more independent life may begin with something as humble and ancient as a handful of lentils. The science says it is worth trying. And the stories of people who have tried it suggest the results can be truly extraordinary.